Hello guys and welcome to Ncert audiobook. In this video we will be covering enzyme catalysis topic of the chapter surface chemistry. Enzymes are complex nitrogenous organic compounds which are produced by living plants and animals. They're actually protein molecules of high molecular mass and form colloid solutions in water. They are very effective catalysts, catalyze numerous reactions, especially those connected with natural processes. Numerous reactions that occur in the body of animals and plants to maintain the life processes are catalyzed by enzymes. The enzymes are thus termed as biochemical catalysts, and the phenomena is known as biochemical catalysis. Many enzymes have been obtained in pure crystalline state from living cells. However, the first cell was synthesized in the laboratory in 1969. The following are some of the examples of enzyme catalyzed reactions. First, inversion of cane sugar. The invertase enzyme converts cane sugar into glucose and fructose. Conversion of glucose into ethyl alcohol. The zymase enzyme converts glucose into ethyl alcohol and carbon dioxide. Third, conversion of starch into maltose. The diastase enzyme converts starch into maltose. Conversion of maltose into glucose. The maltase enzyme converts maltose into glucose. Decomposition of urea and ammonia and carbon dioxide. The enzyme urease catalyzes this decomposition. In stomach, the pepsin enzyme converts proteins into peptides, while in the intestine, the pancreatic trypsin converts proteins into amino acids by hydrolysis. Conversion of milk into curd. It is an enzyme reaction brought about by lactobacilli enzyme, which is present in the curd. Characteristics of enzyme catalysis. Enzyme catalysis is unique in its efficiency and high degree of specificity. The following characteristics are exhibited by enzyme catalysts. First, most highly efficient. One molecule of an enzyme may transform 1 million molecules of the reactant per minute. Second, highly specific nature. Each enzyme is specific for a given reaction. That is, one catalyst cannot catalyze more than one reaction. For example, the enzyme urease catalyzes the hydrolysis of urea only. It does not catalyze hydrolysis of any other amide. Third, highly active under optimum temperature. The rate of an enzyme reaction becomes maximum at a definite temperature, which is called as the optimum temperature. On either side of the optimum temperature, the enzyme activity decreases. The optimum temperature range for enzyme activity is 298 to 310 Kelvin. Human body temperature being 310 Kelvin is suited for enzyme catalyzed reactions. Fourth, highly active under optimum pH. The rate of an enzyme catalyzed reaction is maximum at a particular pH, which is called as the optimum pH, which is between pH values 5 and 7. Increasing activity in the presence of actuators and coenzymes. The enzyme activity is increased in the presence of certain substances which are known as coenzymes. It has been observed that when a small non-protein vitamin is present with an enzyme, the catalytic activity is enhanced considerably. Activators are generally metal ions known as Na+, such as Na+, Mn2+, Co+, Cu2+, etc. These metal ions, when weakly bonded to enzyme molecules, increase their catalytic activity. Amylase in the presence of sodium chloride, that is Na+ ions, are catalytically very active. Sixth, influence of inhibitors and poisons. Like ordinary catalysts, enzymes are also inhibited or poisoned by the presence of active functional groups on the enzyme surface and often reduce or completely destroy the catalytic activity of the enzymes. The use of many drugs is related to their action as enzyme inhibitors in the body. Mechanism of enzyme catalysis. There are a number of cavities present on the surface of colloidal particles of the enzymes. These cavities are of characteristic shape and possess active groups such as NH2, COOH, SHOH, etc. These are actually the active centers on the surface of enzyme particles. The molecules of the reactants, that is substrates, which have complementary shape, fit into these cavities just like a key fits into a lock. On the account of presence of active groups, an activated complex is formed which then decomposes to yield the products. Thus, the enzyme catalyzed reactions may be considered to proceed in two steps. Step 1. Binding of enzyme to the substrate to form an activated complex. Step 2. Decomposition of the activated complex to form product. Catalysis in industry. Process. Haber's process for the manufacture of ammonia. Catalyst, finely divided iron, molybdenum promoter. Conditions: 200 bar pressure and 723 to 773 Kelvin temperature. Nowadays, a mixture of iron oxide, potassium oxide, and alumina is used. Number 2. Oswald's process for the manufacture of nitric acid. Catalyst: platinized asbestosis. Temperature: 573 Kelvin. Process: contact process for the manufacture of sulfuric acid. Catalyst: platinized asbestosis or vanadium pentoxide, that is V2O5. Temperature: 673 to 723 Kelvin. That's all for this video. Thank you for watching.